Hello everyone, my name is John Holt and I'm your host for today's episode of Eyes on Earth, a podcast of the U.S. Geological Survey's Earth Resources Observation and Science Center. So every 8 days, Landsat satellites gather new imagery over every inch of land on the planet. Theoretically, that means Landsat can see any big changes that happen on U.S. soil. In practice, though, it's not quite so simple. From 400 miles up, a green field of corn looks a lot like a green pasture. A deciduous forest looks like an evergreen forest. Either of those could pass for forested wetlands. On today's show, we're talking with Colin Homer. It's Colin's job to turn all that Landsat data into an accurate and reliable record of land cover in the United States. It's called the National Land Cover Database, NLCD for short, and Colin's team just released a new edition called NLCD 2016. Colin Homer, welcome to Eyes on Earth.
Thanks, John.
So let's start with introductions. You're the program manager for the National Land Cover Database, is that right?
Yes, I coordinate the generation of the entire database.
Okay. So what is the National Land Cover Database?
Well, that's a good question. First of all, I'd just like to say a little bit about what land cover means. Not a lot of folks really know that. That's really breaking out where the forests are, where the crops are, where the grass is, where the urban areas are. Those kinds of things are what we call land cover. So what we put together is what we call a database, which is kind of a series of digital maps of what those different land cover types, where they're distributed, how they change across time, and those things feed into a lot of different applications.
So a land cover database is different from a typical map.
Yeah, if you would think of a typical map you might see on a table, we are actually, what a database is a stack of maps. And so we're a stack of digital maps. And what's important about a digital map is it means you can query it. You can ask it questions through a computer. And you can do all kinds of analyses which can look at how things are distributed and how they, where they are found and the amounts that they're found in. And that feeds into a lot of science in terms of where things are distributed and why they impact or how they're stratified in different kinds of applications.
Right. So how much forest do we have? How much cropland do we have? Those sorts of things.
Right. And we can answer all those questions.
How do you tell from a satellite image what is a cornfield and what's a soybean field? How do you chop these things up?
So our eyes, when we look at things, are seeing a certain amount of visible light, and we can ascertain what's there from what our eye sees. A satellite gets to see in other spectrums of light, and we call that a signature. A tree sends off a different signature than a crop might, though they look to our eye the same way. With the satellite, we can discriminate those.
So is it a computer that's figuring all this out, or there has to be a human element somewhere, right?
Yes. So a series of computer programs and models are what are our tools, but we still have humans using these tools, and they have to be smart in terms of what we're trying to accomplish.
So a computer kind of does the bulk of the work, and it's your job as the human intervener, the scientist, to go in and make sure that it's correct and make sure that everything's accurate and all that kind of thing. I think now might be a good time to talk about when you're producing this thing, you're producing a map based on pixels, Landsat pixels, 30 meters by 30 meters, right? Let's talk about that. What is a pixel, and what does that translate to, say, for acres, and how many of them are there in the United States? How many of these things are you classifying?
So a satellite is just taking a picture, and that picture is chunked up into different little squares, which we call a pixel, and different satellites measure the squares in different sizes. So Landsat, which we're speaking of here, is a 30 meter by 30 meter pixel, about 100 foot by 100 foot chunk. There would be about 5 of those in an acre. And there's about 9 billion of those in the lower 48 states. So that's a lot. For me to wrap my head around that, I have to think about, well, if you put 9 billion 30 meter pixels end on end, it would take you 95 years to fly over that in a passenger jet going 550 miles an hour.
Wow.
So those are a lot, even though at first glance you think, well, why can't we do it at a finer resolution? When we're doing a national scale map, that's a resolution that works well for our applications.
Sure, and there are other mapping tools out there, other mapping products out there. We have the USDA cropland database. Cities and states, they have GIS offices. They're putting together all sorts of maps. What makes NLCD different, and what makes it necessary to have the whole country with Landsat?
What the National Land Cover Database offers is, yes, a city or a state may have their scale of sort of land cover that they need, but no one really does a synthesized, harmonized national product like the National Land Cover Database is. So it's relevant at a national scale. That's our niche.
And it's complex too, isn't it? I mean, how many classes do you have?
So in the lower 48, we have 16 classes of land cover. But again, this is a digital map with lots of layers in it. We also estimate the fractional amounts in these 30-meter pixels of forest and shrub and bare ground and grass. And so there's lots of integrated layers in there that feed into making a land cover call.
So you could look at a city and say, this much of it is an impervious surface, and that much of the surface is a road, this much of the surface is that. You can break it down even further from just being urban into these other categories.
Correct.
Okay. Well, who does that? I mean, you keep saying the word users. I suppose now we could talk a little bit about who those folks are. I mean, who uses this? What's it used for?
So if you think of land cover as a general term, most folks don't stop and think it's used in a vast majority of applications. So just to give some sense, we're up to almost 1 million downloads of the National Land Cover Database.
The whole thing, the whole
thing.
Okay.
And it's used in everything. It's used in a lot of watershed runoff modeling. So anything to do with how water enters the landscape and is partitioned on the landscape. Used in a lot of wildlife, getting at what the habitat is for everything from elk to fish to ants to snakes.
To ants.
Ants.
Wow.
We've had a lot of studies done using it to look at different ants and how they're distributed on the landscape. It's used for medical applications to look at where cancer rates occur because different pesticides are used in different land cover types. It's used to see how diseases spread. So knowing where ticks are in the landscape or knowing where mosquitoes are in the landscapes helps them to look at how a disease is going to vector or how a disease is going to spread. It's used in education a lot. We have a lot of students that use it for a variety of things in their education, on and on and on.
Right. So basically any question that you might ask where the type of land cover in your neighborhood is a factor is a place where somebody might use a land cover database like the National Land Cover Database.
Right. And it's even some of the more quirky things I've heard of is, it's been used to cite a cell phone tower in. So, of course, you're going to want to know where the forests are to decide how your signal on the ground is going to be received. And so, or it's been used to cite where an airport runway goes. There's lots of very practical, I guess, uses too you wouldn't think about.
One that always is interesting to me is the census, right? At one point, the census looked at NLCD?
Yeah, so our urban imperviousness as well as some of our land cover products are used to help them define where their neighborhoods are and how they calculate the population inside of those because they have their census tracts, but the percent imperviousness helps them to understand the density or how the population is distributed inside the census tract.
Interesting. So that gets to another sort of interesting piece of what you can use land cover for. You can put an LCD into the mix with a lot of other things and sort of compare and contrast.
Yeah, so land cover as a general rule, just to use an analogy, is kind of the flour in the recipe. A lot of our users will take the National Land Cover Database and do some what we call value added step to it, where they're going to add their own data to it to refine their analyses and get the answer that they're looking for.
Tell me how that works in the context of wildlife.
Land cover would be the first starting point. So, for example, a bird that was tied to a forest, we can tell you where the forest is, give you the amount of canopy there. but they might tie into another database to get at the forest height or to get at the distance from a road or some kind of disturbance. And so they would often put these multiple layers together inside what we call a geographic information system to actually define the actual habitat map.
What kinds of things can you see now with NLCD 2016, looking at every few years what's changing on the landscape?
Well, I'm really glad you brought that up, because the major goal of the National Land Cover Database is to quantify change consistently, both across space, across the nation, and across time. So we now have quantified 15 years of change, and as you mentioned, there's 7 different dates of those that we use to characterize that change. So if you look across the nation, across that 15 years, we've had about 9% of those pixels change at least one time. Now, at first glance, that says, well, that doesn't sound like a real lot. But as you would expect, different change rates happen in different geographies differently. So if you look at the nation as a whole, most of the change happens in the southeast. That's where a lot of forest cropping, they tend to cut their forest in about every 20 years there. So there's a lot of change going on there. A lot of change in the northeast, some change out west driven by fire and then, on down the line. What we're seeing is most of the urban growth is in the south. And if you read the news, you'll hear about the snowbirds moving to the south, where we're seeing that in our database. Urban growth is always a positive thing, but not all the time. If you go to a place like Detroit, we actually have green space coming back in impervious, so that where a city is losing the population, we actually have impervious going away, so it isn't always a positive thing. Seeing a lot of forest loss out west, both from drought and fire. We're seeing some crop change in the Midwest. We are seeing some of the croplands expanding into the grasslands. You might have heard about that in the news.
Where do I find NLCD if I'm not a scientist? And is there a way for me to make sense of it, or is this something that's like college level calculus, where if I haven't had it, it doesn't mean anything to me? How do I find it and work with it if I want to?
So as a federal government, we feel it's our role to create this authoritative data set on the status of the land cover of the nation, and then we put it to a website at mrlc.gov, which is sort of the bulk aisle of the grocery store. That's our job as we see it, is to make sure the product is done well and exists, and users can go out there and get it from that website. We do have a tool where they can visualize the change, and they can also clip out the geography that they care about. But if somebody really doesn't want to add any extra effort in analyzing and understanding it, there's a lot of other websites that take our product and do value-added steps to it. And so I would recommend that a user run a Google on the National Land Cover Database and see some of the other options available.
But ultimately, it's free. This is available to anyone. There are a lot of different ways to get it. And if I don't want to download a GIS software program, although there are some free ones out there, if you want to learn how to use it, get on YouTube and figure it out yourself. If I don't want to do that, you can go right to mrlc.gov, go to where you live, see what the land cover is in your area, and check how it's changed year after year.
Right, and we are trying to get that in. We're trying to get the database enabled on a smartphone and other kinds of things. So in the future, a user can just download an app, and then they can stand on the ground and look at what our database is saying about the patch in front of them.
Excellent. Well, Colin Homer, thanks for stopping in to Eyes on Earth.
Glad to chat. Thanks, John.
We hope you come back for the next episode of Eyes on Earth. Thank you for joining us. This podcast is a product of the U.S. Geological Survey, Department of Interior.